Hello, yes. I'll get started. Welcome again in this talk about LangChain4j. Question, who has attended the talk of Guillaume Laforge on Gemini? Okay. There's going to be a bit of repetition. I mean, he already talked about a lot of concepts that I also will talk about, but I guess that's helpful and you will know it better. So LangChain4j is a little bit over 1 year old. It was started by Dmitry Lyobarsky, who is still the lead developer on the project. And we have over 80 contributors now. We are super grateful to them because they've brought so many integrations with LLMs, other models, embedding models. So there's personal contributors, but there's also a lot of people from Google, Microsoft, AWS, Elasticsearch. So it's super nice, which makes that we have like a very versatile library right now. Okay, so the whole concept of LangChain and LangChain4j is that we're going to use the models as an API. So we're not in this training, data, machine learning part. We're just using models that are already made. So LangChain was first. It's a Python library, and it went completely viral. Was there about half a year before we started. And so it allows you to simply connect to these large language models via API, but then they also build all kind of functionality on top of that. So you can chain different calls and different things. You can interact with documents. You have agents, all that stuff. We found it super cool. So that's why we thought, let's make this in Java. With LangChain4j, all this LLM magic becomes a piece of cake. So let me show you the components. No, let's first get the terminology right. So we're mainly having large language models as our central components, even if we also support image models and hopefully in the future some more modalities too. But when it comes to large language models, there's plain language models, which I would just like, don't use them. If you put something in there, it will likely give you similar results. Whereas after the normal plain language models came the chat models, such as GPT 3.5 Instruct, and also this Gemini and everything. They are trained to listen to your instructions and to answer questions and chat with you. So for most applications, we will use those models. And then there's also embedding models. They're a bit special. They turn text into a vector, a numerical vector that kind of encodes the meaning in the text. And that's really nice because once you have the meaning of your text encoded or of your text fragment, you can use this to compare it to other text fragments and find the most similar meaning text fragments, for example, and use it to label and to categorize things. For example, we'll see some more use cases of it later during this talk. And these embeddings, these vectors, we're going to typically store them in embedding stores, which are optimized to do super fast similarity search over these vectors. Good. So these are the components that you can find in LangChain4j. On the left, we have these language models that are the core of a lot of things we do. But there's also image models, so text to image and image to text is supported. We have prompt templates, which makes the whole prompt engineering a bit easier because you're going to find yourself otherwise sending in the same string, the same text a lot of times. Like if you want to have the model answer a certain way, it's going to be every time the same. So there prompt templates come in. We have memory, because when we want to chat, we want to preferably keep a memory of that. We have tool calling, where the LLM can call our code. We will see all of that in more detail. And then we have output parsers, where you don't have to care about parsing the model output, and we will have it return Java objects, for example. On the right side, you see RAG, Retrieval Augmented Generation. That's a hard word to say chat with your documents, and we have some utility for that. And then the layer above, we have the chains, like in LangChain, but they're not super well supported. There's just some basic use cases. We bet more on our concept of AI services, which is super versatile. You'll see that also later. Here on top, you can see some logos of, for example, OpenAI, Google, HuggingFace, Azure, Ollama. These are all forms of model providers. So we support plenty. And if you want to know which ones we support as of today, because it gets extended all the time, you can go to our repository, which is github.com/LangChain4j/LangChain4j. And when you scroll down in the code and a bit down in the README, you will find examples. The example repo, I can recommend to check that one out. Examples with Quarkus, examples with Spring Boot, documentation, and the tutorials, which are part of this examples repo. And then a lot of useful materials to teach you everything about prompt engineering or whatever you may need, or choose the right model. So you can find that all on our repository. And then, if you scroll on, then here is our integration table. So as you can see, sync completion is that we just support, you send a text in and then you get an entire text back. We also have streaming, where you send your text in and you get token per token back. So a token is typically around 3 characters. Really depends on the models, how they split the text up. And that's, of course, very nice to get it piece by piece, so you can show it immediately. You see which support these vector calculations, these embeddings, image generation, and then a function calling, like letting it call your tools. So as you can see, we just have plenty. Some special ones in there are Ollama, which lets you run the models locally on your machine. Local AI, something similar. And HuggingFace, HuggingFace is also very nice. They have about all open source models out there. You can download them there, but you can also fine-tune them there. And they have also training data, all open source, where you can use to fine-tune or train your own model. Then you can run it on HuggingFace or download it, and then super easily access it from LangChain4j. Okay, let me show you off some tool that bundles a bit everything LangChain4j can do. So I've checked out this example repository. So first thing is that in here, and I'm sorry, I can't zoom in on this, but like for every provider, Milvus, Mistral, Neo4j, Ollama, we have examples of how to connect if you want to get started. It's usually pretty easy. And here is this customer support agent example. Boom. That I want to run for you. So it's a customer support agent for a car rental service. And so what it has in there is that it knows about our terms of use. So we're using reg to get always the relevant parts of our terms of use. And it also has tools to perform bookings and to cancel bookings. They're dummy tools, but it still will call our code. So as a user, I can say, hi, can I cancel my booking? Now, you're going to see a lot of logs mixed in here. I hope you can read it. So, so you see some logging here. And the answer is, sure, I can help you. To proceed with the cancellation, I need your booking number, customer name, and surname. Why is it asking for this? Because we have a tool registered. It knows that it can call this booking cancellation tool when it has these 3 parameters. So it's asking for it. So I'm gonna play a bit down. My booking number is 123456. Let me see if it can handle that. All right. To assist you further, I will also need your full name and surname. Okay, let's do it. That's Klaus. And it's wrong on purpose because, so this is happening, this error message you see in the backend, right? That's not meant for the front end, but we throw a booking not found exception because I put the wrong name in there. And then it says, I'm sorry, but I couldn't help you find the booking. Can you double check booking number, provide additional details? Like, so, oh, sorry, my surname is Heisler, and this is supposed to work because that's the only one that returns anything in our tools. So it retrieved these details. So that's all backend, but the model gets this. Like it knows from when to when my booking was, the booking number and my name. So it says, I have found your booking details, but since your booking period is less than 3 days, cancellations are not permitted. And it knows because we also sent along our terms of use. And even if it would try to cancel it, we will throw a booking cannot be cancelled exception, and it will be able to interpret this with the dates we've given, with the date of today, and with our terms of use. It will puzzle it all back together. So that's quite powerful. Gonna stop the application, yes. All right, so now let's start from the basics, because I hope you walk out of the room today knowing how to get started. A question? Yeah, so the question is, how does the RAG exactly work here? Here, I think we have a little bit of advanced RAG, but you see in the logs that it retrieved one part. I could go look in the details here about segmentation, but I will come back to it later in more detail. So you will know everything you want to know about it. Good. To the basics. A hello world example with LangChain4j. So then I'm gonna again have a look in our examples. We have an empty class here. Okay, so let's do some live coding. It's risky, but it's so easy with LangChain4j that I will totally risk it. So we will need a model to start chatting with. That's chat language model. And we want to connect to OpenAI chat model because they are really easy keys that they can give out. And when we want to talk to OpenAI, we will need a key, absolutely. If you want to try this at home, you can just use demo. So you can use this a little bit. It doesn't do the complex stuff like tool calling, but to get started, you can just use a demo key. If you like it, get yourself a key at OpenAI and put it there. So voila, that's all we need to start chatting with this model. So now we're gonna generate an answer. I have a habit of making typos when I'm presenting and coding at the same time. So we do model.generate. And we're gonna let it say hello Voxed Days Brussels. And then we wanna just print that to console to see, please, what that gives. Okay, let's run this. I need an internet connection as well. Very important. Okay, so there's always a bit of latency. I clicked it twice. Okay, hello Vox Days Brussels. It's great to be here and I'm excited to be part of this event. Good, that is not what I asked it to do, right? So there's another thing. LLMs don't do what you ask them to do exactly. And they will also not return twice the same thing, usually. Hence, you will want to do some prompt engineering. To make sure you force it to really answer what you want, and you have to just deal with it, that it's like non-deterministic, what's going to come out. It has some implications on how you build your app, how you handle errors, and how you evaluate your code. I don't have time to run through the whole tutorial, so I'm just going to say what else is in here and show you the most interesting ones. If you want to set the model parameters, here's an example of how it is done. If you want to use an image model, there's also an example of how that is done. It will probably not work with the demo key, just saying in advance. All the prompt templating, string handling, using variables and strings is in the prompt template class. Streaming is explained, so when you get character or token per token back, that's explained here. And then we will move on to, let's skip this, memory. So often we want to use it to chat. And models in themselves, they're just calculation schemes. You send text and characters or tokens in, and tokens come out. They don't have memory by themselves. So it's up to us to manage that memory. And there LangChain4j comes in really helpful. So it looks a bit like this. You can build up a chat memory. You have the option to set a system message, which is a general instruction for your model. For example, you are explaining this to a toddler, and it will apply for the whole conversation you have. Or in case of our chatbot here, it was like, you are a customer assistant for company, da, 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 da. So applies for the whole conversation. And then we start chatting. So first time we will send in system message, optionally, and a user message. That's what we ask. And we will get an AI message and answer back. If then we want to be able to ask follow-up questions, and we want the model to remember what's been said before, we have to send in both the first message, the first answer, and our second message. And it will give us a second answer that is informed. So that's how it works. We'll see some memory examples later, because they come a bit in all examples. I just right away want to show you a hack of the memory. You can either tell a model to answer in some specific format and try to force it to comply. But there's another way to do this. It's by faking the memory. So it's called few-shot technique, where it's not this one that I wanted to show, where you're going to fake the memory. So you're going to put fake questions in there that you never asked, and you're going to put fake answers that the model never answered, but that are in exactly the format you want it to be. And if you give it a couple of examples like that, and then you ask a question, it will try to comply with how it was answering before. Super good at that. So again, we have a model here. And then we start our chat memory, or our history, so which is just a list of chat messages being a LangChain4j object. And what I do is, I add a couple of examples. So I have here a positive feedback about whatever it was, a phone company or something. And then I add an AI message, the answer of the model, saying, action, forward input to positive feedback storage, because we developers, we also need to get the positive feedback, right? Then a new line, reply, thank you very much, and some very polite reply. So I pretend the model has answered that. I then also add a negative example. So I'm facing frequent crashes, da, 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 my message. And then the answer from the model is, again, action, open a new ticket, and then the subject, crash after update Android. New line, reply, we are very sorry, da, 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 da. What I then do is I add one other positive, one other negative example. I generated those with OpenAI in the first place. And then I add my real message there at the end. I'm adding, how can your app be so slow? Please do something about it. And then I send that whole thing, my whole history, to the chat model, and I do generate. What we see here as well is a streaming response handler, because it's an example where we're going to see the output in streaming. So I bid you to pay attention. It goes really fast, but you see that it comes out token by token. All right, let's clean this up. Now let's run this. So I've not really actively instructed it to answer in my format with action and reply. I've just given it examples. And then the last thing I ask is this, how can the app be so slow? Please do something about it. Now when we run this, watch out for the streaming. Tuck, 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 tuck. There it goes. So action, open a new ticket, app performance issue as a subject, new line, reply, and a kind reply. And I didn't even really have to explain it what to do. So this is a very powerful technique if you have requirements on the output format. All right. Good. Then, my favorite, AI services. LangChain4j invention. So they return pojos, which is really cool, but they do so much more. They're really like a working horse, allowing you to declare in language what the code needs to do. So let's see an example of that. In its most basic form, again, we're making a model. In this case, I'm logging requests and responses because, yeah, and I've put this tiny log properties on debug, so we get to see actually also the logs. We get to see what's actually sent to the model. And the most basic example of an AI service is this one. So an AI service, you declare an interface. And this, we call it assistant. The name doesn't matter. And then it has one method, chat with a string as input and a string as output. So LangChain4j will know, okay, string input, string output, it's just send it to the model, return the answer. And then to actually obtain an instance that we can use, we're going to do AI services.create from our assistant class that defines what has to happen and the model, which we always need. Because now we're using OpenAI, but we can use Mistral, Gemini, anything. So then we have an implementation of this without really coding anything about it. And then we can use this assistant.chat method, that we said it needed to have. And I'm just translating some French text form here. So one can run this now. And yeah, let's have a look at those loggers just so you have an idea what's happening behind the scenes. We have this call to the model. So we have a post and saying like the model, the messages, the user role, it's my question, is translate this thing. That's what we've written there. And then we get the response. So LangChain4j takes care of, wrapping that in a proper call per model type you want to use, and to also parse the answer. So here we see this role assistant gives me the answer. So that's what we're going to parse. So the real answer then of my function is capital gains from the sale of securities and ta-ta-ta-ta. I don't even know if it helps me a lot. I still don't understand it. OK, but this was just a simple chat interface AI service. But now let's start to do the real magic with that. So our second example, I already showed it quickly this morning too. Who was in the talk this morning, by the way? OK, yeah, then I'll go relatively quickly here. So this is, again, an AI service that I declare. And this has three methods. Translate method, a summarize method, and this extract date time from. So how are they now different? You can specify a system message. So this is general instruction. Here saying you are a professional translator into a language. And you can use then your variables of your function to insert here with this syntax by annotating them first. So for the precise syntax, just have a look at the examples and copy it over. And then the other variable we define here is the text. And we use that then in the user message. Translate the following text. There goes our text. So that's for the translate method. It returns a string, a translation. Then the summarize method. There's a system message saying summarize every message from the user into n bullet points, provide only bullet points. So there we see some prompt engineering, because if you don't add this, you will notice if you try, the model will start saying things like, oh yes, here are your bullet points, and then we have a problem parsing that afterwards. And then the two variables in there are our text, which is also our user message. And then this variable n for the bullet points, an integer. And the return type is a list of string. So when we use this method, we just get a list of string out, and we can continue from there. That's pretty awesome. But that's also why it's important that it only gives us the bullet points, or we cannot parse this into a list. LangChain4j takes care of this parsing. And then the last example, user message, extract the date and time from it being the only variable here. And then it gives you back a local date time object. So LangChain4j takes care of adding some stuff to your prompt, saying like answer strictly in this format. And then the model will do this, and LangChain4j will parse it to this type of object. So I have a couple of examples here. I'm going to use I'm going to create this text utils AI service with its three methods. I didn't code anything. I just said what I wanted to do. AI service.create, and then I have my text utils, and I can use the translate method. I'm going to translate hello, how are you into Italian. Then I want to use this summarize method on this text here. It's a text about artificial intelligence. We want it summarized in 3 bullet points. And then we have a list. We get a list back, and we're just going to print it as different points to observe it. And then the last one is a local date time extractor of this text that's about 3 days before the Belgian National Day of 1998, just 15 minutes shy of midnight, So it's really embedded in some random text that usually we could completely not parse in any date-time object automatically before AI arrived. And then this should give us a real local date time, which we're also going to print to console. So let's see what it does with this. Oops. Oh yeah, so I should have switched off the logs, because now we're going to have to find it in there. But anyway, we have our local, local date time object here. That's 15 minutes shy of midnight indeed. The year is correct, and also 3 days before the National Belgian National Day. So correct. Then, we can go find the other ones. Here's the summary in 3 bullet points. That's also correct. And then we wanted to translate some Italian. Ciao, come stai, which is also correct. So that's how it works. Now, before I go any further, I switch this again to info level, so we don't have to search in there. OK. What you can also do with AI services is return your own declared POJO. So we have an example afterwards where we declare that there's a recipe object with a title, a description, steps, and preparation time in integer. And if it's not clear from the object, from the field name itself, we can add a description, a LangChain4j annotation, saying what exactly we want. For example, we want a short title here with 3 words maximum. Also, we've asked it to make every step rhyme with each other. And that's pushing it a bit to the limits. So often it does not succeed. So our recipe object, POJO. And then we create an AI service with one method, create a recipe from, a variable number of strings as ingredients. So the idea is you pull open your fridge and you say, I have this, generate me a recipe. And we get a recipe object back. We also have a toString method when we print this. And then we're going to create a recipe from cucumber, tomato, fondue, onion, olives, lemon. OK, this was a prank for a Greek colleague who said the model should not be able to answer this because this is blasphemy. You don't do this to a Greek salad. And the funniest thing was that he was right, and the thing crashed. And then when we ran it again, it just omitted the fondue. So let's just put this to feta and be reasonable today. I don't want to insult any Greek people. And run this. So we are supposed to get a recipe back in our POJO format. So there we go. Title null. It's not so beautiful. But it's at least the description looks good. And chop, mix, toss with glee, squeeze lemon, and it's ready to be. Voila. It managed to make it rhyme. I don't know why the title is null. So yeah, you can do recalls when it's not working perfectly. Good. Next, we can add tools. Tools, you tell the model, I have this code, I have these methods. You can call it if you need it. And here are the input parameters I need and the input types. And here is the output type you will get out of this. That's really nice. So I have a bit of a dummy example for it, but you can go pretty wild with it. For example, these booking tools you saw in this car assistant agent. So tools, yes. So it works like this in LangChain4j. You have a class with some methods in there, and you can annotate them as a tool in order to let the model know that they are tools. So what we have here is a calculator class with a string length method. I mean, it's a bit silly, but just to show you that it's called string length, calculator, an add for 2 integers, and a square root for an integer. Then there's a console print just for us to see that this method has really been called. And then, oops. Yeah, and then the return is super easy, of course. And we have a description. It's optional, but so calculates the length of a string. I think in this case, it's very obvious what it does. But for less obvious methods, you can put a description there. So we annotated these 3 methods here in our calculator class as tools. Now, if we want our model to use it, we're going to make an AI service again. We make an assistant with 1 method chat, the basic one, string in, string out. And then, okay, we make our model as usual. And then we build our AI services from our assistant class. But this time we're going to add, so our model, we set it, we're going to add these tools as well. So a new calculator class, this is how the model will know. And we also added chat memory. So that's really the easiest way to do it. Just add your memory to your AI service and you're good to go. LangChain4j will take care of the rest. We have a couple of default implementations here. For example, with message window, chat memory with max messages 10. So after 10 messages, this gets cut off. Why do we cut it off at some point? Because our context window, what we can send into the model, is limited. Although I must say that in Gemini, I learned it's 1 million tokens, like 300 million characters, but you also pay per character. So if you want to use that full context window in this Gemini Pro, you pay, I think, $3.50 per call if you use it all. So just limit your memory. It's going to be much, much, much cheaper. To give you an idea of the price, I just know it for OpenAI. Think you can generate about 8 pages of text for 1 cent, if I'm not mistaken. So that's why we cut off our memory at some point. Good. So we have an AI service simple chat method with a memory and with tools. And we're going to ask it this. What's the square root of the sum of the numbers of the letters in the words hello and world? And you know what? Let me first show you without adding the tools. In this case, I've added no tools. Let's see what it makes out of it, because maybe it's perfectly capable of doing this, even without the tools. So the word hello 5 letters, world 5 as well, the sum is 10, and the square root, it looks actually good. But good, if we give it the tools, it will call them, so we can observe that. Because we did some prints to console, right? So now I've added these tools back in, and there we see it called the string length, it called add, it called square root, comes up with the same answer. But yeah, you can think of all kinds of tools that you give it. You can have it clear your database, delete your database, change your database, give it access to your credit card and the internet. So be careful, think twice, but you can make a lot of really useful apps with this. Okay, hence the meme. Okay, now we go into this RAG, Retrieval Augmented Generation. Guillaume already talked a bit about it. So if we ask a question to a language model, it's going to be able to answer us based on what it was trained on, and that's it. So for example, OpenAI GPT-4 has been trained up to somewhere in 2022. Anything since that date, it doesn't know about it. Anything that's specific to our company was not part of the training data set, or it's even private information of us, it doesn't know about it. So what can we do about this? We can make sure that when we ask a question, we also add relevant parts of our documents, / the internet, / from our database. Anything that's relevant for answering our questions, we can send this along. Again, we had the example from Gemini where you can use this entire token window and send so many documents in, but it's going to be very costly and also take quite long. So RAG, also not all models have such a huge context window. So RAG is a way cheaper and more to the point and faster approach to this. So the question is, how do we find the relevant segments in our documentation, GitHub repository? Like, we support out of the box in LangChain4j, PDF, Word, Excel, GitHub repositories, URL, like you can send in really many things out of the box. So how we go and find them? This is where these semantic vectors, these meaning vectors come in, these embeddings. So in a first cycle, we will take all our documents, split them into parts, and then we have segments. We will calculate a vector per segment that encodes the meaning, and then we're going to store in our embedding store the vector with the meaning and the original segment. so that when we get questions from the user, we're going to also calculate the vector, the meaning, the embedding of their question. And we're going to find in this embedding store the most similar vectors and their segments. And that's how we find these most relevant segments and how we give them along with our user question. So what LangChain4j will do is say, like, user question original, and you can make use of these segments, and then we just paste the segments in. And then the language model will be able to give you a more grounded example, and it will hallucinate way, way, way less. This is what's called naive RAG. It's already pretty powerful out of the box. We'll see later that there's more advanced approaches too, because it also has some shortcomings. I just put a link there to easy RAG. That's even easier. That's with our Quarkus integration that comes, if you want to check that. The only thing you have to do to start chatting with your documents there basically is you add the EasyRag POM dependency, you add one line in the properties where your documents are to some folder, and you're ready to start using it. That's super easy RAG. I'm going to show you what naive RAG looks like in plain Java and LangChain4j. I made this little example that I'm pretty proud of, because the documents I'm loading in is the entire LangChain4j documentation. So if you remember well, LangChain4j is about 1 year old. OpenAI models do not know about it yet. So if I want to create examples, I'll have to do it this way. OK, I'm going to walk through this code. Like, you don't need to understand everything right away. You can look at this at home. But what is very nice is that we have an embedding model. So that's going to calculate these vectors that runs in memory. That comes with LangChain4j if you want. There's also, of course, many others that you can use. But for this one, you do not even need an internet connection. I'm going to also, just for the proof of concept, use an in-memory embedding store. And I'm going to do this ingestion of our documents in the same program as where I'm going to ask my question. So if you really build this, make it two separate things, right? You ingest your files once, and you calculate embeddings once. And then whoever user uses your program, the database is already filled. That's the idea. But let's run through it as if it's one big program now. So we need our embedding model to calculate our vectors, and an embedding store to store them with our text segments. Then we're going to make an ingester, where we have a document splitter. We have some default ones again, but then also everything in LangChain4j is an interface. If you're not happy with it, you can implement your own implementation of it. And if you think it's of general use, make us a pull request, and we'll add it. So we're going to split with maximum segment size 300 characters and maximum overlap 30. Imagine we just split dumbly in the middle of a word, then with this overlap, we will probably have the word at least in one of the two. This is a very dumb way of splitting. We also have split per paragraph or whatever suits your data, really. And then we set the embedding model and the embedding store, and we have an ingester. And then we can go ingest all these documents. I've put that in a separate file, goes through every document in that folder and ingests it. So then our embedding store is filled. Then comes this retrieval cycle. So if we want to retrieve the segments that are relevant to our question, the user question also needs to be embedded. So in our retriever, we will add this filled embedding store. The same embedding model, that's important, because they all create different types of vectors of different dimensions, so you can't just swap from one to another and compare. So same embedding model, and then we have some parameters here saying I want maximum 3 results back, the best ones, and I also want them to have a certain minimum score. Just to find out what works best for your data, you will need to tweak these values. And observe a bit what comes out of it. There is a talk by Stefan Janssen just after in also this room, telling you everything about tweaking your RAG system. OK, we're going to add a memory. We have our model, and then we build an AI service. It's again a very easy one. It's a string in, string out thing with a system message saying that it's a coding assistant for LangChain4j, basically. So we have this AI service. We're going to build it. we have the memory, we add a model, and then we add this content retriever, which has the filled embedding store, which has the embedding model all right in there. And then we're good to go, and we can start using this. So it's going to be with console interaction in this example. So you see it ingest all our markdown files from our documentation. That was pretty fast, and because that's running in memory, right? That's not even going to any OpenAI or whatever. So now I'm going to ask, or like, create. Oh, Jesus. Okay. LangChain4j hello world example using Mistral AI, and let's be bold, and let the model generate an answer for the question. What are we going to ask? Whatever. Are we developers? Just whatever. Good. It's a bit bold. Also because it has only 3 fragments. I limited that to 3 fragments, so let's see if it has enough. Oh, great. Tells me that I can. OK. I mean, hey, it's true that you will find it here. OK, but like, yeah, but please generate me the hello world code for Mistral AI. OK, I'm repeating some stuff on purpose because it's one of these limitations of advanced RAG that if I don't repeat it, it's not. If I don't say Mistral AI again, it's not going to find the things with Mistral AI in there. OK, so there we go. OK, cool. A chat language model, Mistral AI chat model. I think that's correct with API key. Very nice. And then perfect. It's remembered my question nonetheless. Are we developers? And then model generate answer. That's wrong. So it's generate. So it's a start, right? It's just to show you what RAG can do. Now, it comes with limitations. If I ask a follow-up question, it will not remember what I said before, in the sense that to find the relevant fragments, it just completely forgets. So we have in LangChain4j also advanced RAG. It works a bit the same, but instead of just a retriever to find the content pieces, we have a retrieval augmenter interface, where you can also just implement whatever you want. But out of the box, we have all this. And these are our default implementations. So let me try this pointer. No pointer. All right. Then, OK, let's start on this side, query transformers. So the problem I just said, you ask about John Doe, and it will find you pieces about John Doe. And then afterwards, you ask, when was he born? And then it's going to embed when was he born and find the relevant pieces. And maybe you have a text with birth dates of plenty of people. It's not encoding this John Doe anymore. So query compressor takes care, compressing query transformer, takes care of grouping all the information from before and making a query that allows you to find it. So it's going to change this for this question, when was he born, into something like birth date of John Doe. Expanding query transformer is just going to change it into multiple questions to just make sure you have all the relevant segments. Then the query routing principle is either something rule-based or either an LLM deciding, should this question go to our semantic retriever, like we saw it, or should it just go straight to the database, or what else do we have here? Should we do a web search? Or should we do a bit of all? And that then launches this query, web search, question, semantic search. So you can have different content retrievers. So we have this embedding store content retriever that we just saw, this semantic similarity with the vectors. We also have a Neo4j, so this graph database content retriever already. And then tomorrow come web search engine content retriever, so go search the web, and SQL content retriever, go query your database. So tomorrow we have a release, and it's going to be in there. I'm pumped. Good. Then once we find all these fragments, we're going to aggregate our content. So in the example, we saw a minimum score and maximum number of parts. That's our default content aggregator, just puts it all together. But we also now have a re-ranking content aggregator. So what often happens is that, specifically in semantic search, you find things that are actually not relevant. So somehow, semantically, they're close, but they're completely irrelevant to answering the question. And usually, this will confuse the model. And sometimes it's going to say things about these fragments, even if you completely didn't ask about it. So the best thing is to kick them out again. And that's what a re-ranker does. It's calling a model that's highly specifically trained on rank or score segments in how much they have to do with an original question. So we get our question, and we get our parts, and it just gives us a score, and you kick out everything that's under a certain score. Yep, and then the content injector is, we have all our segments. We just put our original question there again, our segments, and on it goes to the model. And when you're using these techniques, some of them or all of them, your RAG gets much, much better. Some of these come at the cost of more latency, though. The re-ranking is super fast, but then other things like query routing, it's really an extra call often to the model. Okay. We have a very nice Spring Boot integration and an extremely nice Quarkus integration. So let me demo you some advanced RAG in a full-blown LLM-powered application in Quarkus this time. So I'm going to show you my the one I talked about this morning. There's also link to the code. Forget about the whole tree thing. Should remove that if you want to try this out for yourself. So what I did is I tried to structure this very clearly so you really can find the pieces of the program back. So I have data storage objects. I have 2 databases in there, SQLite and an embedding store. I have my AI services, and then I have the endpoints that communicate with the front end here. It's still running. Let me just restart this. So for using Quarkus, you do Quarkus dev, or if you don't have the CLI, you do Maven Quarkus dev, and then you're good to go. So this will start it on my local host. No. Yes. Okay, I already went there. So I already showed it this morning, right? And I just restarted it. So okay. So my database is cleared again, I think, So let's say that today I'm male and that I'm coming from Germany, and that I said that the food tasted delightful, really heavenly. I noticed that the women had told it tasted like cardboard. And then good coding examples, because this is in theory for a coding workshop. Now when I submit this, first there will be an AI service splitting this, just like the summarizer, but this is a splitter, into things on the same topic. So the food tasted delightful, really heavenly is one, and then good coding examples is that's great split, done by AI. And then AI is going to also put a category here, catering in this case, or examples in the other case. They are in enum, so it's just, these are pojos actually that it's just generating. And I ask it to score it on severity and impact. And I have only positive feedback, and I told it to give it a 0 on urgency and severity. So, but when it's a problem, it does this quite well. And then we have this feedback analyzer, where we can see what kinds of feedback we've gotten out of here. And then we have another chatbot where I can ask, what did the man find about the food? Now, why am I asking this example? Because we have a semantic search on the food. So it's delightful and heavenly. That's great. And if more people put their feedback in there, you can really go explore. Oh my God, there were a lot of complaints about room temperature or something. What did people say? It's a very nice way of exploring your feedback. So what have I put in our vector store? I've just put this alone. I've not encoded that it was a man or that it was 30-year-old or something at all. So when it asks it questions about food, it will probably find anything that has to do with food very nicely. But on top of that, I've added metadata filtering, which is another thing of advanced RAG. Just wanted to show you what that looks like. So it's in my chat socket. And here I'm going to add a language model SQL filter builder. And I give it this table definition. And I've said, like, OK, gender, birth year, nationality, and severity, I've added as metadata on my embedding store. And then when I add this to my content retriever, this querying filter, it's going to generate these queries for me. And that's how it managed to find only the things that the man asked. Good. No, OK, I loved this meme. Yeah, I just added this because I thought maybe if everybody had seen Guillaume's talk, I need some extra content. So I'm going to just go super fast because it's not really part of the talk, but just this is a chatbot that sold a car for $1 to a customer that managed to say, like, but yeah, is it legally binding? And it, like, he prompted it into saying yes, 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 and it was legally binding in the end. So just a warning, when you build apps and you confront the public with them. This is a very nice thing, like just unable to perform API call to GPT. So you want to have some error handling in there because it's not always returning what you want. There's an example of how prompt injection works. So do not trust LLMs. People will always find ways to make them do things that you told them not to do. They managed to override whatever instructions you gave them. So think of that when you build your application. This is like an application, like go fully crazy with what you let the LLMs do and integrate them in your app. And just everywhere where I have these exclamation mark, it's just watch out. So watch out what data you send in there, because if you're using OpenAI, were you actually allowed to send your customer data to OpenAI? Just ask yourself these questions before you do these things. How biased is your training data set? Is there anything in your training data set, if you trained your model, that the user should actually not get to see? When you let it send emails, go to the internet, or give it access to your credit card, put some hard checks in place, or put like a human as a tool that before it can do anything, you have to give it permission to actually do so. And then the answer, of course, can be biased, can be wrong. So you need to deal with all those things. OK, I'm going to just skip those things. And voila, because time is up. Here are the important links of our repository. So most of it is linked at github.com LangChain4j/LangChain4j. And now you know where our repository is. You know where to put your pull requests if you make some extra extension functionality or if you want to fix bugs on a rainy day. We're really happy if you help us out. Thank you very much for your attention and have fun with it.